Hello. Today we will go over one of the free response question in 2010 calculus AB. So the question is, let R be the region in the first quadrant bounded by the graph y equal to 2 square root x and the horizontal line y equal to x and y-axis as shown in the figure. So this is a figure they're talking about. This line is 2 square root x. This is line equal to 6. Find the area of R. So even they think they are nice. They give us the intersecting point right here. That's intersecting point right there. But you know that they just give us. But if they don't give us, we need to. How do we find out this one is 9, 6? By finding the intersection of these two. So we can see 2 square root x is equal to 6. Then you can divide both sides by 2. And square root x is equal to 3. Then x is equal to 9. Right? X equal to 9. And that's why you have x equal to 9 and y equal to 6. So that's why we have the intersection is 9 to 6. Since this is the in case that they don't give us the intersecting point, but this why I just do extra here to let you know how to find out the coordinate of this point. So at this moment, this is 9 right here. All right, so let's find the area. All right, the area, it will be integral from a to b of the f minus g dx, where f will be the above and g will be below curve. In this case, above curve is y equal to 6 and below is y equal to 2 square root x, and the integral you can see is from 0 to 9. From 0 to 9 of 6 minus 2 square root x dx. This one is equal to 0 to 9 of 6x minus 2. So the integral of square root x will be x to 3 half over 3 half. Then, so since we already take the antiderivative, you don't have to find the integral anymore. And we need to end point right here, 0 to 9. Let's simplify a little bit here. Then 6x minus. So this one, when you simplify, you have 4 over 3 x to the 3 half. And you put the endpoint 0, 9. Now you can substitute 9 in here. Let's make 6 times 9 minus 4 over 3 times 9 to the 3 half. And of course, you substitute 0 in there. You have 6 times 0 minus 4 over 3, 0, 3 half. So we know this section is equal to 0. So you just concentrate on these items. That's 54. Subtract 4 over 3. 9 to the 3 half. That means 9 to the 1 half. And to the third power. Then you have 54 minus 4 over 3. And 9 to the 1 half is 3 to the third power. Then you cancel here that you have 2, because 3 to the third and 3 to the first power. Then you have 3 to the second power. Then 54 minus 4 times 9 is 36. Then the answer is 18. So that's the area of the R. Okay? So let's go to the next one. Right, but do not evaluate the integral expression that give the volume of solid generate when R is rotated about the horizontal line, y is equal to 7. All right, so this one I would like to redraw this a little bit here. So this is 6. All right, so this is 9, and this is the region R. Now let's draw the line y equal to 7. We know this. We know this is 6, right? This is 6. Now 7 is above the line equal to 6, so this is 7 right here. This is y equal to 7, and they want us to rotate r around the y equals to 7. So we can draw a little bit here. For example, this one will be like this, and this one will be like that, right? And think this line will be like this line, right? And this one will be roll around here and move down here. So you can see the curve will be like this. So you can see that's the region around the y equal to 7. So when you do the volume, then you when it's volume, then you think this one, this is axis of revolution. This one we can use washer method. Here's how washer method work. From any point in axis of revolution, you draw it out. So it meet the region at 2 points. This point at beginning hit the region R as this point A, and hit the later on it hit the size of point B. For this case, because it hit two regions, then you have two radius. This is the first radius here, this is a small r, and the second is big R. We know that this is washer method, so area volume will be integral from a to b pi integral from a to p of big R square minus small r square. In this case, is the bar we draw here move along the x-axis, so this one will be dx. Where big R is equal to, big R is different from line equal to 7 to this one. So the distance from 7 here, y equal to 7 to the y equal to 2 square root x. So that means equal to 7 subtract 2 square root x. Right? From 7 subtract 2 square root x. And small r is from 7 to 6. So that means it's 1. Right? So then you just, and then the same thing we have. AB in here is from 0 to 9. 0 to 9 of big R squared. That means 7 minus 2 square root x squared minus r, small r squared, 1. So it's dx. So that's it, because they don't want us, we don't need to evaluate it. So that's how we calculate the area, the volume of the r rotated about the horizontal line y equal to 7. So this one we use washer method. This one we could use, I think we could use shell method too. All right, so let's move to C. The region is base solid, that is the base of solid y, for each y, where y is from 0 to 6, a cross section of the solid taken perpendicular to the y-axis is rectangle whose height is 3 times the length of its base in the region R. Write but do not evaluate the integral expression that give the volume of the solid. This one I'd like to draw a little bit here so you can see the three-dimensional. Right, so let's draw a three-dimensional. So this is y, this is x, and this is z. Three-dimensional, you don't have to, but it's good to draw it out so you can see it. Y equal to 6 is right here. This is y equal to 6. And the curve is like this. This one, x is equal to 9. And this is the region R. Right? So what they said is the cross section is perpendicular to the y-axis. So you draw like this, perpendicular to y-axis. This one will be perpendicular to the y-axis, right? Perpendicular to the y-axis, right? And then they have the rectangle, right? Rectangle height is 3 times the length of base. So this is the base. So the height will be 3 times the length of the base. So that's a rectangle, right? The height is 3 times the length of the base. So this is the base, and this is 3 times of the base. They ask us to find out the volume when the bar move from 0 to 6. Okay, so in here we can draw the bar B is here. This is B, right? And we can say that, okay, so let's we know that the volume in the cross section is equal to integral from a to b of a, and could be dx or dy, right? It depends on it's dx or dy. So let's find out in this case, because the bar move along the from 0 to 6, and they mentioned right here y from 0 to 6 here, so that's mean we use dy, right? Because it's moved along the y-axis, the bar move along the y-axis. So in this case, we have a is equal to 0, b is equal to 6, and a, this is rectangle, is equal to length times width, and length in this case is 3b, and width here is b, right? However, this one, you can see that if I pick up any point in here, so this is x coordinate and this is y coordinate of that point. Right, so you can see that b is equal to x. Right, so what we can do is, the volume is equal to integral from 0 to 6 of x times 3x dy. So that means integral from 0 to 6 of 3x squared dy. However, we have to convert this one to y because y here is the variable. We have to convert x to y. And you know that this point on the graph, y is equal to 2 square root x, right? Then we can do, then we square both sides. Y squared is equal to 4x. Then you have x is equal to y squared over 4. In this case, we plug them in, substitute 3 times x squared will be y to the 4th times 16 dy. And just make a nice look. 16 integral from 0 to 6 of y to the 4th dy. So that's the answer for C. All right, so that's how you do for C when you do the volume with the cross section. B, the volume, count the volume, but using the washer method. And A, we find the area of the region bounded by F and G. All right, that's it for today. Thank you for watching and see you next time.